Hello, students. Let us work in the following problem of mechanics of materials. So you have a solid circular post ABC that supports a load of 2,500 pounds. This is P1 acting at the top. And there is a second load P2, which is uniformly distributed around the shelf at B. So it's basically a force, a distributed force acting here in this kind of ring surface, right? So the diameters of the upper and lower parts are diameter of the upper part, diameter of AB is 1.25 inches, diameter of BC, that is the lower part, is 2.25 inches. So they ask you to calculate the normal stress, sigma AB, in the upper part, and they say if it is desired that the lower part of the post have the same compressive stress as the upper part, what should be the magnitude of P2? So we want to find what is the value of P2 such that the normal stress, in this part that have a largest area, of course, is similar to the normal stress that we have here, in this other region in the upper part. So the first that we're going to do in this case is to calculate then the normal stress in AB. So sigma in AB would be equal to P1, that is the force acting on the upper part, divided by the area of the region AB, or the part of the part AB. Now, what is the area of AB? AB is a region, or is a part that have a circular area. So the closed sectional area of this part is a circle, right? So we have a circle here with a diameter AB. So the area of AB would be pi times DAB squared over 4. So to find the normal stress, the only thing I have to do is just to substitute in here. So my normal stress in AB is P1 over pi DAB squared over 4. Okay, so it will be 4 P1 over pi DAB squared. And then we substitute, it will be 4 times, what is the magnitude of P1? We're talking about 2,500 pounds. Divided by pi times, what is the diameter of AB? 1.25 inches. And then we perform the calculations, and we're going to get that the sigma AB, so the compressive stress in the region AB, so in this cross-sectional area that you can see here, would be, in this case, 2,037.2 pounds per square inches, which is approximately 2,040 pounds per square inches. So there we have sigma B. Now, what is the next we have to do? We want to find the magnitude of P2 such that the stress in this region, right, is equal to the stress in this other region. So we have to start just saying, that we need to get the sigma in BC, so the compressive normal stress in BC. must be equal to the compressive normal stress in AB. So now we know what is the magnitude of this compressive normal stress in AB, that is 2040 pounds per square inches. So what we have to do is just to find the expression, for the compressive normal stress in BC. And in this case, this compressive normal stress in BC would be equal to, and then P2 is acting only in this part, that it's like a ring, you know. So we really have that where uh, P2 is acting, we have in the inner part the diameter of AB, the other part is the diameter of BC. So P2 is acting on this part, and the area, you know, in this case, would be the area of BC minus the area of AB, right? So there is where P2 is acting, okay? So what we have to say this is P2 divided by the area BC minus the area in AB. So this would be now, of course, when we make the analysis, right, of the area, we have that this is P2 over the area in BC is by dBC, diameter of BC squared over 4 minus pi diameter of AB squared over 4, right? So we can just work a little bit more here, okay? So we can say that this is P2 over, we factor pi over 4 out, and we get d of BC squared minus d of AB squared. So I will solve for P2. When I solve for P2, I will bring all these part multiplying to the left. So we'll be multiplying sigma BC. So I can say that P2 will be sigma BC. So the compressive stress in BC that is equal to the compressive stress in AB times pi over 4 times the BC squared minus the of AB squared. So now we just substitute, we get 2,040 pounds per square inches times pi over 4 times, then we have 2.25 inches square minus 1.25 inches square. And then based on this, right, we get now that we perform the calculation. P2 will be approximately 5,600 pounds. So it's exactly just exactly 5,607.7 pounds, which is approximately 5,600 pounds. And that would be then the magnitude of P2, which is a distributed force, right? That is going to be the magnitude of P2. If we want to have the same stress in the region AB than in the region BC. So the key here was to identify that to solve part B, I have to make, the normal stress in BC equal to the normal stress in AB, and to understand that this normal stress in BC, you know, uh, as P2 is acting only in this part in form of a, or in this area in form of a ring, you have to then find the quotient of P2 with the area of this ring, right? So this is just the key to solve this problem.